my name is Teacher Desiree Lim, or you can call me Teacher Des. Did you all bring your origami papers with you?
Yes.
Okay, so let's have some origami activity. So let's get our paper. So let's fold it like this. Okay. First, we fold it into two and form a triangle. Okay, good. And then, after that, let's fold it again into two, like this, and form into a triangle. Then next is to form it again into two, like this, going upwards. And then the last and final folding is this one. Okay, so you should form a triangle like this. Okay, that's good. Now, using your scissors, kindly cut a portion. So your triangle should be like this now. And cut a portion of that triangle like this. Okay. So after cutting, your paper, kindly open it again. And then your paper should look like this now. Okay. See, magic. We were able to form 8 smaller triangles from the big paper. Now, what I want you to do is to choose one triangle and name it triangle A. Okay. Choose any triangle you like. So for our example, let's have this. And this will be our starting point. And then after choosing A, let's choose another triangle, triangle B. Okay, now, from this one, from point or triangle A to triangle B, what can you observe about the triangle? From here to here. Okay, did you notice any change in the movement? Okay, so the triangle looks like it flips, right? Or it turns upside down. So from here, it flips like that. Question. Did the triangle become smaller or bigger? Did it become smaller or bigger? Yes or no? It's still the same triangle, right?
Yes.
Okay, so it's still the same triangle, nothing changed to its size. How about, did it turn into another shape? Okay, no. It did not turn into another shape. It is still the same triangle. Now, let's observe again from point B, or triangle B, to triangle C. Do you notice any movement again of the triangle? Okay, it looks like it flips sideward, right? But did it change the size of the triangle? No, it did not change. It's still the same triangle, and it did not change into another shape. It did not become into a circle or a rectangle, right? So we can see here from point A to point B, the triangle only changed its position or location. It did not change its shape. It did not change its size. Then at the same time, from point B to C, still the triangle is still the same triangle, only in a different location. So we call this change in position or location transformation. So transformation happens when the position of the figure changes, but its shape and size stay the same. Okay? Is it clear?
Yes.
Okay. So now let's go back. Okay, for today, we will be discussing figure transformation. And for today's lesson, we will discuss the first kind of figure transformation. So to understand the first kind, let's go back to our origami activity. Let's pretend that we will cut this portion. Okay? And let's observe its movement. Okay, because we said that in a transformation, there's a change in location, so there is movement. Now, let's study deeper into the movement. So, we all know that the triangle consists of 3 points, right? Now, how did the triangle move from point A to point B? Okay, so let's start with the first point. From here, it moved here. Okay? So that's the point after. And then the second point here has moved to this point. Okay? And the third point here moved here. Okay? There. And from here, the triangle B is being formed. Okay, you see the movement? So it looks like it flipped upside down. Right? And we call this the point before, the points before, and the points after the corresponding points. Okay, and these corresponding points are very important when we move a figure or any kind of shape. Okay, so again, corresponding points are the before and after points that are moved in the transformation. Okay. Is it clear? Yes. Let's have point A here. Now, I want point A to move into a different position. And that position is the point here, point B. So, how will point A move to be able to reach to point B? What do you think? To be able to move here, point A should go downwards first, right? How many steps? 1, 2, or we call this units. And then, to reach B, point A has to move how many steps going to point B? 1, 2, 3, 4, 5, 6. Okay, 6 points going to the right. Okay, and 6 points. No, not 6 points, 5 points. Let's all see. 1, 2, 3, 4, 5 points going to the right. So that's the movement A should take to be able to reach to point B. There. Okay? That understood. Now, why is this important? So we will be using this arrow AB to move line XY. Okay, line XY. So we will move line XY into a different location following the direction of arrow AB. Okay, and let's again remember the direction or the movement of AB is to go down 2 units and then go to the right 5 units. So that's what we are going to follow to move points XY here. Okay, so we already know the direction, and the second step that we will take is to move it. And point X here goes down 2 units because that's the movement of our arrow, and then goes to the right 5 units. And plot the what? This is the corresponding point of point X. Remember the corresponding points a while ago. It's the point before and the point after. And then we have another point here, Y, that has to be moved also using the same direction of arrow AB. So Y goes down 2 steps and goes to the right 5 steps. And this will now be the corresponding point of point Y, which is point D. Now, since we have 2 points already, we can then, okay, so again, corresponding point of X is the C, and the corresponding point of Y is the point D. And then from here, we can now draw a line. Okay? Now, if you notice, from this point, from this position, or from this location, y seems to slide this way, following the direction of arrow AB. Okay? So, in this kind of movement, wherein the shape or the figure seems to slide to a direction that is same to our given, is what we call translation. Okay? Translation happens when a shape slides in a single direction for a certain distance along a plane. Okay? It says here, single direction and certain distance. Let us see what does that mean. So let's go back to the direction of arrow AB. Okay, single direction. So the direction of arrow AB, again, it was to move 2 steps and 5 steps to the right. Right? So that's the direction. And this is the same direction that X has to take to be able to reach to C. And same with Y, it goes also the same direction to be able to reach point D. Okay? And there's another criteria. It has to have same distance. Meaning, whatever is the distance of AB here, that should be the same distance with XC here and the same distance with YB here. Okay? Is it clear? Okay, now please take out your books and open it to page 133. Okay, it says there in question 1, for example 1, triangle PQR is translated from ABC in the direction of the arrow. Okay, which direction? Arrow KL. And which length? The length of arrow KL also. Okay, so there's the arrow KL there. And then observe the movement for the direction of the arrow KL. Because that's what we are going to use as the guide to be able to translate the triangle into a different location. Okay, so let's discuss that. The first is to determine the movement. And what do you think is the movement of arrow KL? Okay, let's see. K goes down. How many units? 2 units. And then goes to the right again. How many units? 7 units. So we have to take that in mind so that we will be able to do the second step, which is to plot the corresponding points. Okay, to plot the corresponding points, we keep in mind the direction. So let's have A, B, C here. And this is a triangle, so we have 3 points to transfer or to translate. Okay, following the same direction of arrow KL, so A goes down 2 units and then goes to the right 7 units. So this will be the corresponding point of point A. We call it point P. And then the second arrow or the second point is B. C, I mean, it goes down 2 units and then goes to the right 7 units. And its corresponding point is point R. And the last, so B goes down 2 units and goes to the right 7 units. And we will now be able to plot the corresponding point, point Q. Okay, and since all the points are complete, we are then ready to connect these 3 points. So A is being transferred here, C being translated here, so B being translated here. And then we can now connect these 3 points to form triangle PQR. Okay, and keeping in mind the same distance and the same direction. Okay, so there's a question in your book that says, what relationship is there among AP, BQ, and CR that link the corresponding points in example number 1? What are these AP, BQ, and CR? So let's go back to our illustration. So if we remove the two triangles, and here they are, the AP, the BQ, and the CR. And the question is asking us, what is their relationship? What do you think? Okay, you notice they go to the same direction. Okay, and they are of the same length, right? So these segments connecting the corresponding points are all parallel and their lengths are equal. So what do we mean by parallel? Parallel, meaning extending in the same direction everywhere with the same distance and not meeting. Let's check if they are really parallel. Okay, so same direction. If this is the direction of KL, that's also the direction of AP, CR, and BQ, right? And what do we mean by same distance? Everywhere, same distance. So meaning, the distance between AP and CR is the same going anywhere, whether you go down or you go up. Okay? And same with the distance between the CR and the BQ. So whether you go up or you go down, it's the same. And if that is the case, therefore, these three lines or segments will not meet. If you extend from here going there, they will never meet. Same with this one. So this line cannot meet with this line, as well as this line. So that's what we mean by parallel. And there's another relationship, that is, they are equal. Meaning, they are of the same measure, quantity, amount, or number as another. Okay, so which measure? It's the measure of ROKL. So whatever is the measure or the length of ROKL, that is the same for the ROAP, ROCR, and ROBQ. Okay? There. So that's the relationship. They are parallel and they are of equal length. Okay, so keeping those in mind, same direction and same distance, we are now able to translate triangle ABC from this point to its new position at this point. Okay, so if you notice, the triangle seems to slide in one direction and it has been translated. Okay, following the direction of ROKL and the length of ROKL. Okay, is there any question? Now, can we do our exercise or question number 2 found in your book on page 133. So it says there, construct the shape that is translated from triangle ABC in the direction of the arrow. Okay, which direction? Arrow MN for the length of MN. Okay, so I'll give you 5 minutes to do that. Okay, and your time starts now. Okay, so we have to keep in mind, again, first is to determine the movement. Okay, so you have already determined the movement now. Okay, that's good. And from that movement, so we can now go to the next step, which is to plot points to plot. Okay, by now you should be plotting, or everyone's done. Okay, I think this is easy. Okay, now let's try to answer. Is everyone done? Just to make sure. Okay, so let's answer the question number 2 on the board. Okay, can I ask again? First is to determine the movement first. So what do you think is the movement? Okay. Okay, the movement is to go down 1 unit, right? And then move to the left, how many units? 1, 2, 3, 4, 5, 6 units. Okay, so that's what we are going to follow. So since you are able to determine the movement now, let us plot the corresponding points. Okay, there, 1 unit and 6 units. So we can now go to the second step, which is to plot the corresponding points. Okay, can I have some volunteer to plot the corresponding point of point A? Teacher Michelle? Michelle. Okay, plot the point, corresponding point of point A. And name it point B. It's not point P, in the book it's X. Okay, and then another volunteer to plot the point or the corresponding point of point C and name it point Z. Teacher Hot. Any volunteer? Great. Can you do that on the board, please? And name it point Z. Okay, and the last point is point B. You can plot the corresponding point of point B. Jera, can you do that on the board, please? And name it point Y. Okay, very good. So, after knowing the direction of arrow and N, we were now able to plot the corresponding points. Okay, so A was moved to this point, and it's now point X. Then C moved here, and it's now point Z. And then the last point is B, which moved to this location, and is now named as point Y. And from here, we can then connect like this, here, and there. So we are now able to connect these 3 points and form a new triangle X, Y, Z in a different location. Okay? So keeping in mind single direction, which is the direction of arrow MN, and then that is the same direction for arrow AX, CZ, and BY. And then not only single direction, but they have to have the same distance or equal length. So the length of AX is the same as MN, is the same as CZ, and the same as BY. Okay? And if we have these 2 things in mind, single direction, equal length, then this triangle can be translated to a new position or location at this point. Okay? Is that understood? Do you have any question? If you have no questions, please take note, okay, of your assignment that is found on pages 134 and 135 in your textbook, and that is about the other kinds of transformation, which is the rotation and the reflection. Okay, and also please don't forget to bring protractor and compass next meeting. So for the rest of the period, I have prepared worksheets for you to answer. Okay, so I will give you 5 minutes again to answer that worksheet. If you are done, you may submit your worksheet. So let me just read the instruction. It says there, construct the shape that is translated from quadrilateral WXYZ in the direction of arrow EF for the length of EF, and name the new shape as quadrilateral ABCD. So for this activity, you will now have 4 points to translate to form a quadrilateral. Okay, is there any question in the instruction? Okay, you may start now. After 5 minutes, you start now. Okay. When you're done, you may submit your work. I guess the seat work was easy. All papers here? Okay. So, again, let me just remind you of your assignment. That is to read in advance the next kind of transformation, which is rotation and reflection, found on pages 134 and 135 in your textbook. And don't forget to bring protractor and compass next meeting. Okay, is there any question? Okay, so that's the end of our lesson for today about translation. Next meeting, we have rotation and reflection. So, I'll see you next meeting. Goodbye, class.
Goodbye.